the most massive stars in the universe. When you look up at night, you will notice that we are surrounded by stars. Some are bright, while others are fainter. This could be because they are far away, or it could be because they are naturally faint. The only way to comprehend it is to compute their distance from us. The brightest stars are the largest, according to the spectrum classification of stars. Smaller stars are typically not as brilliant. But which are the most enormous stars? Is there a list of the universe's most massive stars? Thank God, the answer is positive. We'll go over them in this video. The most massive of them is more than 215 times the mass of our Sun. Hello and welcome to Zeey. Subscribe to our channel and ring the bell to receive our daily videos. Astronomers examine the properties of stars and strive to calculate their distances, temperatures, and masses. What motivates them to do so? The answer is straightforward. They want to know how they are born, live, and, inevitably, die. Among them, perhaps the most exciting event that may occur is the death of a star, because a star can die as a black hole, neutron star, or supernova depending on the mass it had when it was born. Some of the stars are merely a tenth of the mass of the Sun, which isn't even a large star. Others are the size of hundreds of suns. We previously stated that larger stars are usually brighter. But take note, largest does not always imply most massive when it comes to stars. According to theoretical studies and models, the maximum mass of a star is around 120 solar masses. What we truly mean is that a star cannot remain stable if it exceeds the mass limit of 120 solar masses. That is what theory suggests. However, reality is always more complex than models. There are stars that are brighter than that. We know this because we witnessed it. Astronomers are working to figure out how they can exist. Our 13601. Our 13601, for example, is 215 times more massive than our Sun. This star carries a lot of weight. It is currently the most massive star ever known to exist in the universe. However, this is not its sole record. It is also the most luminous, with a luminosity roughly 9 million times that of our Sun's. Sunglasses are useless against this monster star. Our 13601 is part of a supercluster, a jumbled region loaded with stars. It may be found in the Tarantula Nebula, which is part of the famous Large Magellanic Cloud, often known as the LMC. Its temperature is around 46.000 K, which is maybe the temperature of hell. The cluster is visible in the far southern celestial hemisphere, so I apologize if you are from the northern. The distance to a 13601 cannot be established directly, although it is thought to be roughly 50 kiloparsecs, which is the same as the distance to the Large Magellanic Cloud. WR101e. WR101e is another huge star with a mass greater than 150 times that of our Sun. Unfortunately, we know very little about this massive astronomical object. We can call it a Wolf-Rayet star. What, you've never heard of a Wolf-Rayet star? So you're looking for some rapid pills of star evolution? Wolf-Rayet is the lead actor. They are big stars in an advanced stage of stellar evolution, losing mass at an alarming rate. They have limited lifetimes and are thus relatively rare objects, with masses typically larger than 25 times that of the Sun. We know of roughly 220 in our own galaxy, but astronomers believe the Milky Way may contain 1,000 to 2,000 such objects, the most of which are buried by dust. Another well-known and huge star is located in the Sagittarius constellation and is encircled by the Peony Nebula. As a result, it is known as the Peony Nebula star. What exactly is it? It's another Wolf-Rayet star. It is in particular a class blue hypergiant, identical to a 13601. It has 150 solar masses and is a really massive star. Its radius is around 100 times that of our host star. Could you fathom such a massive star? Because I'm having difficulty doing so. If you're inquisitive, the constellation of Sagittarius is home to a plethora of magnificent astronomical objects. M24, for example, is plainly visible. M24, commonly known as the small Sagittarius star cloud, is a vast naked-eye expanse of Sagittarius stars, clusters, nebulosity, and other objects. It can be seen with the naked eye as a big detached portion of the Milky Way. Binoculars and small telescopes are excellent for viewing the object. M24 is said to have the highest concentration of individual stars seen in a single binocular field of vision, with roughly 1,000 visible. It is not to be confused with the adjacent large Sagittarius star cloud, which is located about 10 degrees to the south. The small Sagittarius star cloud is not a true deep sky phenomenon, but rather the result of a rare alignment between the Earth and the galactic center. We would anticipate this location to be densely packed with interstellar dust, yet we are gazing through a breach in the dust by chance. As a result, thousands of distant stars, clusters, and nebulae that would otherwise be veiled are now visible. M24 spans a volume of up to 16,000 light-years in depth. M24 is located 7 degrees north and a bit west of the dazzling teapot asterism, Cos Borealis. The open cluster M18 and the Omega Nebula M17 are located to the north of M24. In the same binocular field of view, all three items are visible. M23 and M25 are open clusters located a few degrees west and east of M24, respectively. Charles Messier found M24 on June 20, 1764. During the months of June, July, and August, it is best observed from southern or equatorial latitudes. Let's continue on to see some more huge stars. HD 93129A. This is a blue hypergiant, which means it is extremely hot and extremely large. It is most certainly one of the Milky Way's most massive stars. It is located in the NGC 3372 nebula in the constellation Carina and is rather close to us when compared to the other stars described above. This star's mass is calculated to be between 120 and 127 solar masses. It is a binary system, and it is the heavier of the two due to its companions' only 80 solar masses. When it comes to Carina, you may add HD 93250 to the list of blue hypergiants. It possesses a mass that is approximately 118 times that of our Sun, but little else is known about it. Pismis 241A and B. Pismis 241A is a strangely named star. It is a blue variable that may be found in the Pismis 24 open cluster. What do you think? You've never heard of a blue variable supergiant? We're back with another cosmic dose of stellar evolution. The luminous blue variables, LBVs, are a very new type of colossal supergiant. These are the most luminous stars in a galaxy and are easily spotted in extragalactic systems. They are also known as S-Dor variables after its Large Magellanic Cloud prototype. Their amplitudes range from less than 1 magnitude to more than 5. They are also known as Hubble-Sandage variables because they have extended years timescales for temperature and luminosity fluctuations, and they frequently eject shells that create pseudo-photospheres, leading their spectral types to change from O to F. P Cygni, a galaxy member of this class, is well recognized for its fast rate of material loss and irregular light changes. Pismis 241b is the sister of Pismis 241a. As you can see, astronomers have a lot of fun coming up with names. This star, like its sister, is a 100-plus solar mass star in the Pismis 24 region of the Scorpius constellation. We've talked a lot about the most big stars in this video. But what motivated us to do so? What is the significance of studying massive stars? Be sure to like or dislike the video before finding out the answer to this question so that we can continue to improve and make these films better for you. Also subscribe to the channel by clicking the bell to ensure that you don't miss any of our weekly videos. Consider the opening of a well-known work by Robert C. Kennicott of the Stewart Observatory in Arizona. Over the past few decades, it has become clear that the influence of massive stars extends well beyond the confines of their immediate stellar systems, the article on the importance of big stars in astrophysics states. Massive stars' radiation ionizes their interstellar surrounds and has a significant impact on the subsequent development of stars in their environments. Massive stars also play an important part in the formation of neutron stars, black holes, and the broad range of high-energy events and processes connected with these objects. Nonetheless, it has become clear in the last 5 to 10 years that the reach of huge stars is even greater than we previously realized. Observations from a fleet of spacecraft, as well as deeper ground-based observations from a new generation of telescopes, have revealed the profound influence that concentrated injections of energy from stellar radiation, winds, and supernovae can have on modern starburst galaxies, influences that presumably replicate those that occurred in the galaxy population billions of years ago. These feedback mechanisms are currently regarded to be critical for shaping galaxies' current mass and luminosity functions, determining the structure of low-mass galaxies, and enriching galaxies and the intergalactic medium and heavy elements. Alright guys, this video ends here. Thank you for tuning in. Do you have a thing for stars? Did you enjoy this video about the biggest ones? Let us know in the comments, subscribe, and I'll see you on the channel again soon.